Hi class, for this video we're going to look at the chi-square distribution and we're only going to be looking at the calculator for the areas. So it's only going to be problem 4, 5, and technically 6. Now here's the basic idea for the chi-square distribution, and for this particular problem your calculator is going to be evaluating the areas. Each of the chi-square distributions that you see here are based on degrees of freedom, so technically you would have to get n. And then you subtract one value, that's going to be the degrees of freedom. Now, let me show you where to find the actual commands on the calculator that we're going to be running. All of your commands are going to be under the second and then distribution. And then you're going to scroll all the way down to the chi-square CDF. So you have to be very careful. The chi-square CDF or the command, it's going to use a lower upper bound and then also degrees of freedom. So you're going to be punching in 11. So once again, you're going to select second and distribution and then scroll down to the chi-square command. And also all of these chi-squared or distributions are used in error formulas for later topics in the course. Now for this particular one, it's asking about area. And you're basically typing it in as follows: lower bound, which is from approximately 2.1. Obviously, your hand sketches are not going to be to scale. And they go all the way to 5.1, which is going to be our upper bound here. So what you're typing in is you're activating the chi-square distribution. And in this case, from 2.1, comma, to 5.1, and then you have to be very careful. You're using degrees of freedom. This command is going to calculate the total area under the curve from technically 2.1 to 5.1 from the chi-square distribution. So please run it. And then since it's asking for area, you're going to need a sentence. I put the command here just so that you guys can run it. We have to be very careful. So the chi-square distribution goes theoretically all the way to the positive infinity, and then it technically may not go all the way to the negative infinity, but the calculator for unbounded problems is going to require a very large value on the right and a very negative value on the left. This one doesn't actually involve that case because it's going from 2.1 to 5.1. But that's actually it for problem 4. Don't forget to put some sort of a sentence. Let's take a look at problem 5. Now, problem 5 deals with an unbounded problem because all they want is theoretically at 3.17, which is here, you're going to be using 21 for the degrees of freedom. But the calculator is going to ask a very large value. So that's why I typed in the calculator 100 or 1,000. And then in this case, obviously this is not to scale, but I'm getting that's 0.999 or approximately 1. So this area here, it's technically approximately 1. And then it is okay if your sketches are not to scale. That's because, well, for the project, we are going to use the appropriate graphs to scale. So that's actually it for 5. The one that could give you a problem, it's going to be 6. Now, 6 is asking below, and that means that's 1.112. And in most of the cases, it's only going to go from 0 and above. But the calculator, on certain models, it'll give you an error. So you're typing in a very large negative value, and then the upper bound at 1.12. And notice that our area, it's almost 0 here. This is the notation for scientific notation. So that's actually it for areas. You're always running the chi-square CDF. And also, if let's say you don't have this command, you need to email me so that we can find an alternative way for you to find the areas. But most of the calculators do have this command. The one that we're not going to have and we'll use tables, it's going to be to find a specific critical value, which I have that in a separate video.